Problem 8. Find the value of the following expression. Well, we know that when we have alternating series, we typically don't know how to solve them. So let's first rewrite it into a series that we do know how to solve. We know how to solve 100 plus 98 plus 96 plus all the way down, I'll give some more numbers, plus 94 plus 92 plus all the way down to plus 4 minus 2, right? Or plus 4 plus 2, because this is the sum of arithmetic series. An arithmetic series is equal to the first term plus the last term times the number of terms divided by 2. And we can obviously solve for this very easily. But this is not the form that we want. We know that negative 98, negative 94, and then negative 90, so difference of 4s, all have a negative sign to it, but they all have a positive. So what do we do about it? Well, how do we get from positive 98 to negative 98? Well, we obviously subtract this by 2 times 98, right? Because the first time I subtract 98 with 98, right, what do I get? I get 0. And then what do I get after I subtract it the second time? 0 minus 98 gives me negative 98, which is what I want. So I subtract 2 times 98, but then by symmetry, subtract 2 times 94. And then we do this all the way until we subtract what? We subtract 2 times 2. So what we have here is we have two arithmetic series to solve for. The first arithmetic series is this series right here. That's the first one. But the second one is negative 2 parentheses times 98 plus 94 plus 90, right? Plus all the way down to plus 6 plus 2. These are the two arithmetic series that we need to solve for to get the answer. So now that we have simplified into two easily solvable arithmetic series, we can now solve it. For the first one, I'll call it S1. What is S1 equal to? Well, the nth term is equal to the first term plus n minus 1 times the common difference. So what is the first term? The first term here is, we can start from the tail, right? The first term is 2 plus n minus 1 times the common difference of 2. So this must be equal to 2 plus 2n minus 2, so that's equal to 2n. So starting from n, the first term is 2, the second term is 4, etc. 2n is equal to 100, therefore n is equal to 50. So we have 50 terms in this series. So S1 will be equal to the first term of 2 plus the last term of 100 times 50 divided by 2. Now I'll call this arithmetic series S2. What is the sum of S2? Well, S2, right, we'll solve for the same thing. A's of n is equal to the first term, and let's call the first term 2. The first term will be 2 plus n minus 1 times the common difference of 4. So that's 2 plus 4n minus 4, so that's equal to 4n minus 2. Where the n is equal to 1, we get 2, right? And all the way until 98. So 4n minus 2 is equal to 98. Therefore, 4n is equal to 100. Therefore, n is equal to 25. So we have 25 terms in total. So S2 will be equal to the first term of 2 plus 98 divided by 2 times 25. So now we know that we have 2 plus 100. So we have 102 times 50. So we have 102 times 25, right? Subtracted by 2 times this, which is equal to what? 100 times 25. We factor out 25 to get 102 minus 100, right? So then what we get this to become 2 times 25 gives 50. So your final answer should be 50, and that is choice C.